Hi, this is a catch-up on where I am with the power distribution for the InMoov. This is my original unit that I was using, which I've been using for several months now. That's got two VU and amp meters on it, because I was going to actually have dual power. So these three were going to be like 5 volts and these three were going to be 6 volts. So that would have shown me, 5 and 6 volts on those. And also the current draw on the unit, but I wanted to add switches onto it, and then decided to go for the Castle Creations Beck units to power separately the various servos, rather than having two master power supplies, if you see what I mean. I was going to have a 5 volt and a 6 volt bench power supply. I've changed the whole way I'm going to do it with the Becks. So that's the old unit, and as I say, it was it worked, but it was all a bit cramped in there, as you can see. So it wasn't perfect. So that's version 1. The new one I've just made, or just finishing off, is this unit. And this is going to mount on the back of the get it in camera. This will mount on the back of the InMoov, which I'll show you in a minute. So this has got, just to show you how this works, I've got a master on off switch, which is also a kill switch, so it's like an emergency switch. I'm just powering this off a 9 volt battery at the moment, just to show what's going on, or 8.87. The battery runs down. These are quite nice displays. I thought I wasn't really paying attention when I bought that. I was thinking I was buying a slightly enhanced version of these, but this one arrived, so which is great actually, because it's a nice unit. So this has got voltage, it's got current on it, if you can see it. Yes, you can. It's got any energy consumption and wattage, which is quite interesting, because inside here I've got the 7 Beck units that I bought, the voltage regulators, which I've got on another video, but I'll take this apart in a minute. And these switches will be, this is a master power on, but these switches are going to be powering the individual Becks. So at the moment, although I've got power coming into the unit, I'm not drawing anything. And I've wired it up, so this is going to be, switch 1 is going to be hand left, switch 2 will be hand right. That's going to do the neck. These don't light, by the way. I might put LEDs on here or something, but it's not really relevant. This is going to be the head. This one's going to be a direct out, so it's not actually going via the Beck. It's just whatever voltage comes in, it's going to go straight back out. So, and as I will be running ultimately at 12 volts, it'll be going. This will be driving the two Easy B units, which are not driving the servos, so it's just pure control, software control. This one's going to be driving the torso. This one's going to be driving arm left and arm right. So these three are the more powerful Beck units, and I've got these running these last three set at 6 volts, and these first 4 set at 5 volts. And as I say, that's just a straight through one. But as you bring them on, you may, if I just show, just make sure you can see that in the camera. We're actually drawing 0.1 of an amp, and 0.8 watts, just having the Becks in line. And so there is a bit of, I suppose that makes sense, because we are drawing power, converting down. But so it's quite useful. You can actually see what's going on there. So as I say, so I've numbered these. These are the outputs, and these will be going straight to my little distribution boards. So output 1, which I've got here, this will mount on the back of the InMoov, and this cable will sit inside the InMoov. Hopefully, I'm trying to create space. So these wires will pretty much go straight to my breakout devices. Couple would need extending. The ones into the head will need extending, and the ones into the arm, the ones to the arms actually reach, as you will see. So the torso will reach, the 2 arms will reach, the hands obviously go via ribbon cables, get extended, and the neck will reach on these, and the head has to go via a cable into the head itself. So most of these won't get extended, so I'm keeping short cable runs. This is 1.5mm flexible cable, so I don't want any power loss, or as minimal power loss as possible. So if we look at cable number 1, if I can find it, which is that one, I should have, just to prove it, I should have 5 volts or 4.97 volts on that. Just turn my meter on again. That's cable number 1, switch on circuit 1, and I'm running at 5.72, so that's going through the BEC, so that's dropping down from the 8.6 coming in. Just make sure you can see that in the glare, and through the BEC and dropping down to 5 volts on the thing. The last 3, as I was saying, these 3 here, which is, let's do that one for example, number 8. That will be running at 6 volts, or I think it comes out 5.9 or something. 5.95, yeah, 6 volts effectively. So as I said, as I was showing in the previous videos, that's regardless of my input voltage, that will be the current I'm going to be, that will be the voltage I'm going to be driving the servos with, and I can always change that if I want to change the servo power. So these, as I say, will connect straight into my little breakout boards. So cable number 1, cable number 8 rather, will go in, and I've also got indication on there what voltage I'm driving at. So if I turn that off, I've lost power. So I'm quite happy with this. I should really 3D print this. I bought this box, but I'm not very good at 3D printing CAD design at the moment, which is what I'm teaching myself at the moment. So my next version will be an actual 3D printed version of this, but this will do for the time being. Otherwise, I'll never get the job finished. Just to show you a bit more about this, this is up to a 50 amps, so it's got a current shunt mounted on the back. Sitting in there, which you need to actually be able to control, to monitor the current. That's the back of the PCB board going on inside. So I'll take this apart and I'll quickly show you what's going on inside. So we'll just pause for a minute. As you can see, I've just bolted this through with some M5 bolts. I've actually ordered some M5 black Allen head bolts just because they look a bit smarter. So rather than having the silver bolts, these are going to be black Allen heads, Allen key bolts on the front there. So it's not really finished at the moment, but it's working anyway. So this comes apart. I'll take that. Just drop voltage off it for a minute. Now it's quite busy in here because the box is could do with being slightly bigger. Now you can see, hopefully you can see, inside I've got the BECs sitting on a PCB board, which I bought, sitting inside. The PCB board's just sitting on the back there, which I just had to slightly cut down to fit in the box. So they're the BEC ones, and they're the BEC 2s, those 3 at the bottom. So they're doing this. They'll all go up to 6 volts. I mean, I've just I could have bought either type, but I was just trying different versions to see what they're like. So they're running at 5 volts, and I've got these running at 6 volts. Those ones, so they're going to be doing the shoulder arm, the 3 large servos, the 805s in the shoulder. So that's rotate and up and down and whatever, and plus that one's going to be doing the torso. So again, that's going to be driving 4 of the large servos, 2 on the rotate this way and 2 on the tilt on the lower stomach. And as you see, there's 7 of those, but there's 8 switches. So one of them, as you will see, well, I'll just show you what else I've got going on in here. To be able to program them, I've cut these back. These are the programming wires. So I've left these in. These ones come with 2 sets of wires. They come with a voltage cable output, which is wired onto the PCB. So the output's onto that PCB, which connects to these screw down terminals here, PCB mounted screw down terminals, and then these wires are wired into it. And the second output, which is for the programming, I've cut short and just re-terminated. So I've stripped them back, just put a bit of heat shrink. So these were really quite long, these ones originally. So I've just, because I want to keep them in there. If I'd had more space, I'd have wired these onto a little header pin so you can plug it in, but I just don't have the space inside. So I've kept these on tails. These ones, these 4, don't come with a second output. They've just got the one output. So I've wired the main output onto the PCB, and then wired these in parallel onto the PCB, if you see what I mean, and then just taken the volts out. So we've got hot and cold, or the plus volts and ground and signal coming out, and wired onto the PCB inside here, and then these wires cut off and terminated onto those same connections, and the plus and ground volts go to these pins. So we're just taking the voltage out onto those. But so these are for future. You can use the programming little module to plug in, and these are just pushed down here just to get them out of the way. If you can see in there, it is busy to say the least. That's the back of the switches. I try to keep fat cable just because I didn't want to get any current loss going on at all, or sorry, any voltage drop. I've got a bus bar across the bottom of those switches, so that is my plus volts, and just going into the switches, into the various switches which go after there. One of those switches, that cable there, goes straight out because it doesn't go through the EZB, through the BEX. That's the control for that's power 4 EZB. That's my common coming in. Inside, you can just see that ground wire's coming in and is just looping across all the ground terminals, or 0 volt terminals. So plus is coming in via the switch and down to that rail. These tiny wires here, which I didn't have any thicker wire. These don't have to be that thick because these are just monitoring wires, just for the back of the unit. There's no power going. It's purely monitoring of what's going on in there. There's no load going through this unit, if you see what I mean. So these can be a lot thinner, but I will actually make these slightly thicker, just because they're a little bit weedy anyway. So that's what's going on in the unit, and it all works. So I'm quite happy with that, but it is very busy. I've left this loose so I can just push this in, and it does actually click in rather than hot melted in. These are just hot melted onto the PCB. These PCB headers, screw down headers, as you can just see there, are soldered onto the back. The track of the variable is just going this way, and then I've just cut. I think you can probably see underneath, actually. Yeah, you can see underneath there. I've just soldered the various terminals onto the bottom of that, so the track's going that way. I've cut it all back down there, so it's not shorting out at the bottom. So that's my power distribution, and that's going to mount on the back of the InMoov, which I'll show you in a few seconds. Okay, this one with the rewire of the InMoov power. I used to be running it at 5 volts. I've now bought a new 12 volt power supply, a 30 amp power supply. I actually bought a 40 amp, but it was faulty, so I'm back down to 30 amp. And I've now properly installed the EasyB 2 control units. I've got obviously one here which is board 0 and that's board 1. To break out the power to everything, I've brought out the signal pins only plus a ground to little breakout boards, which you can just see in here, which are a couple of little PCBs I've got in there. And those PCBs, so the actual signal wires go down and are soldered onto the PCB in there. They connect to the ribbon cable, which just plugs in underneath. So, for example, that is eyes or head. So you can see in there. Just make sure you can see that. Yeah, you can. So these are the incoming signal wires, and then they're broken out to a ribbon cable connector, which is exactly the same pin out as Gail's original system. Because as I say, I've had all the original cabling, so I'm reusing as much as possible and just reconfiguring it. So that will plug in there, and that ribbon cable will just plug into the back there. Let's get that back in again. And that particular one goes up to the head. So on those circuits, I have got some feeds off this board, which are just going to the last 6 pins, and the first 6 pins I've got some coming off this board, because I've actually got the eyes wired off board, the second board, board 1, effectively, and the neck rotation up and down and tilt I've got coming off the head coming off this one. So head, or I've got eyes written on there, the breakout board here is doing the head and the neck all together in one go. I was going to split the neck away and separately power, but I'm not going to. That comes down, its power lead is coming down here, which will go onto my power distribution board that I showed you earlier and will plug up in a minute. So that's the lead. We'll supply power into a little one of Gail's little PCB breakouts, which is sitting in the head there. So all of these are going off to various different parts. As you can see, yeah, you can just see that. Cable number 4, for example, is going onto a separate little breakout board that I've made here, which I was showing a slightly different version earlier. That's got a little voltage indicator on there. So the power, that's cable power 4, which is sitting in one of these. That one goes off to the hand. I've got to get power to the hand. I've wired it as originally done. So I've got the servos plug into one of Gail's little breakout boards which I've left in the forearm, which comes up, plugs into this, which is this cable coming in out of the arm here. It's a through connector, so it's plugging into this board here, and at that point it's picking up power. And so this ribbon, which goes off in this black tubing inside and then comes out here, plugs in, doesn't contain power. So these ribbons have just got signal and ground. So signal, effectively the signal's coming out of here through my little distribution boards here, through these black cables into the arm, and at this point voltage is added, and the volts are coming in on these white cables, which are coming out of here, which will go into the distribution board. So that is the basic throughout. In here you can just see I've got distribution board, power boards here, and that's going to be doing the left shoulder. So that's going to be all 3 motors, the forward, backwards, the rotate, and the tilt, the lift outwards. On that one for the left arm, and that one's going to do exactly the same for the right arm. Power will connect into here straight off my little distribution board, so it's not going to have an extension power lead, it's just going to go straight in to keep the power leads as short as possible. Signal will be going through this ribbon cable here, So again, signals coming in. I've just lost the length of it inside. So it's actually going from there to, you can just see it there. It's underneath here, number 3. It's there. So it's a fairly short cable going from there to there, but I'm just losing the excess inside the InMoov because there's quite a bit of spare. It's quite a bit of space inside the robot, so I'm getting rid of as much cable as possible inside it. I'll spin it around, you can see that in a second. So as I say, just to recap, so that's going to be doing the left arm, that's going to be doing its right arm. Power is coming in separately to each point, so the power goes in at the last moment. Same here, we've got the hand distribution going on there. So these boards are doing the hands, not the arms. So that's the arms, that's the hands. Down here we've got the torso. So this cable number 6 is that one there. Again, I'm just losing the excess in there. And the power will go in there. And as my power distribution unit sits there, the cable's just going to plug in there. So again, I've got a voltage indicator. So that board and that board are the same, and they've got the fuses on them, as you can just see in there. These aren't fused, just for the hands. What else have I done? I've got power coming in. I'm running these at 12 volts straight off my power supply, off the mains power supply. So the mains comes into the distribution board. 12 volts is going straight through to those, and then I'm dropping down through the BECs to the other units on the switches. So everything else is running at 5 and 6 volts, but running at 12 volts. Just here I've got a power supply for the NeoPixel, which is sitting inside for the front. I've also got a power lead going off here, that's running at 12 volts up into the head, and that's going to be supplying via another voltage reducer for the power amplifier for the audio, and also the little LED in the eye. The LED's got a built-in resistor, so I don't have to bother about running in resistors. On the on-off switches for the actual EZBs, we're going in with just the normal plug-in power lead there. I bought these little switches for a couple of pounds off eBay, I think it was, and they've just got little on-off switches there. It was quite useful originally when I was just powering these individually. They come down to, they're just joined up there, and they're going to plug into the power distribution board in the same way as these. So they're actually going to have a master switch for those two, but I've also got the individual switches. I've just left them in there. That is the back of it. I'll just swing it round. Just for the moment, I've taken out the Xbox, which would sit in, or does sit in the front there, just so I can get inside the unit. And as you can see, I've just pulled these cables just to create some space. The Arduino's just sitting in there. I'm going to fix it in there properly, but for the minute it's just slotted in there. There is space. There's quite a bit of space inside. The reason I haven't completely fitted it in there is I'm going to wire that to the voice command. I've seen a little sketch which is sound to line effectively, so I can connect that up via the either the audio from the audio to the amplifier, so it'll get the audio feed from, so what it's saying, it'll just pulse in time. That's the plan anyway. So I've just slotted that in there. I've just got to program that when I get around to it. These cables will fit inside. They do fit inside. I've just been messing around with them, and then the Xbox will slot back in front. Sorry, there's a couple of fillers that go in there which are just in a drawer, just taken out. There's the detector I've just got to put in, the sense detector. That's just got to go back in. I'll do that later. That's the front of it. I will show you the head wiring, so I'm just going to pause it and move the camera.